Warm welcome from Bharat Institute of Higher Education and Research. Myself S. Balaji, Assistant Professor, Department of Electronic and Communication Engineering, and my topic is Classifications of System from the course Signals and System. Classifications of System. The systems are classified into the following categories: linear and nonlinear system, time variant and time invariant system, stable and unstable system, casual and non-casual system, invertible and non-invertible system, and last, static and dynamic system. So all these 6 types of systems are comes under the classifications of system. So first type is linear and non-linear system. A system is said to be linear when it satisfies superposition and homogeneity principles. Consider two systems with the input as x1 of t and x2 of t and output as y1 of t, y2 of t respectively. And according to their superpositions and homogeneity principle, t of a1 x1 of t plus a2 x2 of t is equal to a1 t of x1 of t plus a2 t of x2 of t. I'm just splitting this equation into two values. So that is a1 t1 x1 of t plus a2 t2 x2 of t. So t of a1 x1 of t plus a2 x2 of t is equal to a1 y1 of t plus a2 y2 of t. So this is satisfy the conditions homogeneity and superposition principles. If it satisfies superposition principle, then this system is said to be linear system. From the above equations, it's clear that a response of overall systems is equal to response of individual systems. Example, y of t is equal to x square of t. So y1 of t is equal to t of x1 of t. I'm substituting here by applying here. I'm having two separate values, that is y1 of t, y2 of t. So that's why I'm separating the values. Y1 of t is equal to t of x1 of t. That can be written as, so from the given questions, I can apply y of t is equal to x square of t. No? So in the place of y1 of t, I can replace x1 square of t. Similarly, for y2 of t is equal to t of x2 of t, that is equal to x2 of x square 2 of t. So by adding these two equations, t of a1 x1 of t plus a2 x2 of t, I will get a1 x1 of t plus a2 x2 of t the whole square, because I have to square the output. So by given questions. So by checking this, so this t of a1 x1 of t plus a2 x2 of t is not equal to a1 x1 of t plus a2 x2 of t the whole square. Therefore, the a1 y1 of t plus a2 y2 of t is not equal. Hence, the system is said to be nonlinear. A second method is time variant and time invariant system. A system is said to be time invariant if its output and input characteristic does not change with time, then the system is called time invariant. The example for time invariant is y of n is equal to x of n plus x of n minus 1. A system is called time variant if its input output characteristic changes with time, then it is said to be time variant system. The example for time variant system is y of n is equal to x of minus n. The condition for time invariant system is y of n comma t is equal to y of n minus t. So if y of n comma t is equal to y of n minus t means, then the system is called time invariant. If it is not equal means, then the system is called time variant. So let us see some example for time variant and time invariant. Whether y of n comma t is equal to t of x of n minus t, so that is equal to input changes. So y of n minus t is equal to output changes. So please note down values. For input change, uh, it is denoted by y of n comma t. For output change, it is denoted by n minus t. So this is the first example. Y of n is equal to x of minus n. So I want to check whether the given sum is time variant or invariant by applying the superposition and by applying the values y of n comma t. Y of n comma t is input changes. For y of n comma t, wherever I find n values, that is from the given questions they given n, so in the place of n I have to substitute minus t. So for n comma t, so here y of n comma t is equal to t of x of n minus t, that is equal to x of minus n minus t should add here in input changes. For output changes, y of n minus t, wherever you find n, in term of n, I can replace, I want to replace n minus t. So therefore, y of n minus t is equal to x of minus of n minus t. Therefore, x of minus of n minus t can be written as minus n plus t. So check here. So my input value is x. The input value is x of minus n minus t. I'm getting. For the output values, for the output changes, I'm getting x of minus n plus t. I'm getting. So compare these two equations. If it is equal means then the conditions is time invariant. If it is not equal means then the condition is time variant. So in this sum, y of n comma t is not equal to y of n minus t. Therefore, hence the system is time variant. So let us check one more example for time variant and invariant. So the second questions they given y of t is equal to 2 plus x of t. So the delay input by t naught, that is the input changes, is y1 of t is equal to 2 plus x of, in the place of t I need to replace minus t naught. So t minus t naught I am replacing here. But for output delay, I have to replace input delay. I have to add minus t naught next to t. But in the output delay, I have to replace t minus t naught in the place of. So y2 of t is equal to y of t minus t naught. Therefore, 2 plus x of, here I am having t. So I want to replace t minus t naught in the output delay. So the place of t I am replacing t minus t naught. So let us check y1 of t and y2 of t. So y1 of t answer is 2 plus x of t minus t naught. For y2 of t also we got the answer, same answer, 2 plus x of t minus t naught. Therefore y1 is equal to y2 of t. Hence the system is time invariant. So if y of n comma t is equal to y of n minus t means the system is time invariant system. If it is not equal means then the system is time invariant system. So that is the definition for time variant and invariant. If the system is said to be time invariant if its output input characteristic does not change with time. If it does not change with time means then the system is time invariant. If it is changed with time means then the system is time variant system. And next system is stable and unstable system. A system is said to be stable only when the output is bounded for bounded input. For a bounded input, if the output is unbounded in the system, then it is said to be unstable. So if the system is stable only when the output is bounded by bounded input. If the output is unbounded in the system, then it is said to be unstable. So for a bounded signal, let us see the example for stable and unstable. So from the example 1, they given y of t is equal to x square of t. So x square of t is the amplitude is finite. Let the input is u of t. U of t is unit step bounded input. then the output is will become, in the place of x square of t, I have to replace u square of t because unit step bounded input we have. So let the input is u of t, then the output will also will become y of t is equal to u square of t. U square of t is equal to u of t, that is equal to bounded output. So here, when the output is bounded for bounded input, then the system is called stable. Hence, the system is stable for the example one sum. So similarly, for check out the example 2, y of t is equal to integral of x of t into dt. Let the input is u of t, like similar to example 1. So u of t is unit step bounded input. Then the output y of t is equal to integral of u of t into dt. So integral of u of t into dt is equal to ramp signal. So ramp signal is unbounded because amplitude of ramp is not finite. It goes to infinity when t tends to infinity. Therefore, if integral of u of t is a ramp signal, so ramp signal is unbounded signal. Hence, the system is unstable. So this is the definitions, and we have seen two examples for stable and unstable. And so the system is said to be stable only when the output is bounded for the bounded input. If the output is unbounded in the system, then it is said to be unstable. So next step system is casual and non-casual system. A system is said to be casual if its output depends upon present and past input and does not depend upon future input. So for the non-casual system, the output depends upon future inputs. So what is the difference between the casual and non-casual means? If the output is depends upon present and past input means, then the system is called casual system. If the output is depends upon the future input means, then the system is called non-casual system. So let us see the example for casual and non-casual system. So y of n is equal to 2x of t plus 3x of t minus 3. So for the present value t is equal to 1, substitute t is equal to 1. If I substitute in the present value t is equal to 1, as system output will become y of 1 is equal to x of 2 into x of 1 plus x 3 into x of 1 minus 3 is minus 2. Here, the system's output only depends upon the present and past input. So why the output only depends upon the present and past? Because the given present value I have given t is equal to 1. So 1 is a present value. But for that 1, the output what we got minus 2 I'm getting and 1 I'm getting. 1 is a present input and minus 2 is so by comparing the present value of the input values, the present value t is equal to 1. So by comparing the present value t is equal to 1, I am getting the output x of minus 2. No? So minus 2 is the past input. So the system output only depends upon the present and past input. If the output depends upon the present and past input means, then the system is called casual. So let us take the example 2. The y of n is equal to 2 into x of t plus 3 into x of t minus 3 plus 6x t plus 3. So let us consider for present value t is equal to 1. I'm substituting the present value t is equal to 1. Then the system output will become y of 1 is equal to 2 into x of 1 plus 3x into 1 minus 3 is minus 2 plus 6x 1 plus 3 is 4. That is x of 4. So y of 1 is equal to 2 into x of 1 plus 3x into minus 2 plus 6x into 4. Here the system output depends upon future input. Hence the system is non-casual system. So what is casual and non-casual system is if its output is depends upon the present and past input means then the system is called present. I mean casual. If the output is depends upon the future input means then the system is called the non-casual system. So in the example 2 sum, so let us check I have given the present value t is equal to 1. So for the output, I'm getting x of 1. X of 1 is a present value because in the input, I'm getting y of 1. So present value. So for the first value, I'm getting present value for the plus 3x into minus 2. Minus 2 is past value plus 6x of 4. So comparing this input, x of 4 is future. So therefore, x of 4 is future. So the output depends upon the future input. If the output depends upon the future input means, then the system is called non-casual system. So next is invertible and non-invertible system. So a system is said to be invertible if the input of the system appears at the output. That is, if whatever the input which I given, the same input if I get in the output means, then that system is called invertible system. If the input and output is different or varying means, then the system is called non-invertible system. So let us check this diagram. So I'm giving the input as x of t and transfer functions I'm getting as h1 of t, and this transfer functions I'm transferring to h2 of t, that is invertible system. So from going to h2 of t, the output which I getting is y of t, that is equal to x of t. If the input I'm giving is x of t, output also I'm receiving x of t. So if the input of the systems appears at the output means, then the system is said to be invertible system. So y of s is equal to x of s, that is y output is equal to x of s into h1 of s into h2 of s. Since h2 of s is equal to 1 divided by h1 of s, I'm substituting in the place of h2 of s 1 divided by h1 of s. So this h1 of s and h1 of s will cancel each other. The remaining is x of s. Then therefore x of s, y of s is equal to x of s. That is y of t is equal to x of t. Hence the system is invertible system. If it is y of t is not equal to x of t means, then the system is said to be non-invertible system. So what is invertible and non-invertible system? If the input of the system appears at the output means, then the system is called a invertible system. So the next system is static and dynamic system. So next system is static and dynamic system. If the system depends upon the future and past values of the signals at any instant of time, then it is known as dynamic system. Unlike a static systems, these are unmemoryless systems. They store past and future values. So what is static and dynamic system is? If the what is static and dynamic system is? The system is depends upon the past and future value of the signal means, then the system is said to be dynamic. If the system is depends upon the um, present value or instant value of the signal means, then that system is called a static system. So a dynamic system is otherwise called as memoryless system, and static systems, these are non-memoryless systems. So let us see the example for static and dynamic system. So y of t is equal to x of 2 into x of t. So the example 1, they given the sum as y of t is equal to 2 into x of t. For the present value, I am substituting t is equal to 0. The system output is, if I substitute t is equal to 0, I will get y of 0 is equal to 2 into x of 0. So hence the output is only depends on the present input, because in the input I am giving a y of 0, output also I am getting x of 0. Obviously x of 0 is the present input. So therefore, if the if the output is depends upon the present input, means then the system is memoryless or static. So let us see the example 2. Y of t is equal to 2 into x of t plus 3 into x of t minus 3. For the present value, t is equal to 0. Substitute the present value, t is equal to 0. If I substitute the present value, t is equal to 0, a system output is y of 0 is equal to 2 into x of 0 plus 3 into x of 3 minus 3, because in the place of t I have to substitute 0. So 0 minus 3 is minus 3. So here the input which I given the present value t is equal to 0. So 0 is the present value. So in the output I am getting x of 0. So this is present. But here x of minus 3 is past. So here x of minus 3 is the past value of the input. So here x of minus 3 is the past value for the present input, for which a system required memory to get its output. So as I said before, if the system depends upon the past or future value of the signal, means at the instant of time, means then the system is called dynamic system. So therefore here I am getting x of minus 3 is the past value for the present input. Therefore the system is dynamic system. So totally in classifications of systems, we have seen totally 6 type of systems. So what are the systems? Are linear and non-linear system, time variant and invariant system, stable and unstable system, casual and non-casual system, invertible and non-invertible system, and static and dynamic system. So linear and non-linear systems is the linear systems, when it satisfies the superpositions or a homogeneity principle, then the system is called a linear system. If does not satisfy the superposition theorem, then that system is called non-linear system. Time variant and invariant means y of n comma t must be equal to y of n minus t. So if it satisfies this condition, means then the system is called time invariant system. So if y of n comma t is not equal to y of n minus t, means then that system is called time variant. So we have seen 2 examples for this time variant and invariant. So and third method is stable and unstable system. So when the output is bounded for the bounded input, means then the system is called stable. If the output is unbounded in the system, then the system is called unstable. So we have seen 2 examples for stable and unstable. Next is casual and non-casual system. If the output is depends upon only upon present and past input, means then the system is said to be casual. If the output is depends upon the future input, means then the system is called non-casual. So we have seen our 2 examples for casual and non-casual. So what is invertible and non-invertible? So if the system is said to be invertible, if the input of the system appears at the output, means then it is invertible system. If the input of the systems differs at the output, means then the system is called invertible system. So last is static and dynamic system. So if the system depends upon the past and future value of the signal, means then the system is called dynamic system. So dynamic is otherwise called it as memoryless system. So if the system depends upon the present or instant value of the signal at any instant of time, means then the system is called static system. So we have seen 2 examples for a system and dynamic, static and dynamic system. Thank you.